quieter. While the sunspots still turned through, they decayed slightly the last day, and the solar wind is calming back down now after the impact yesterday. The total event can be seen here, where a mild to moderate solar wind event triggered a level 3 geomagnetic storm. The strong event is over, but reverberations could come today. For a quick breakdown of why this is unexpected and why this means bad news for Earth's magnetic field, see that video from last night, link below. As for those reverberations today, they are accompanied by the ionospheric recovery. This always takes about a day to begin and can lead to a surge in electrical issues during those reverberations. Not like the electrical problems haven't started already. Tend to look for electrical events like fires or glitches, aircraft issues including navigation, or large-scale system breakdowns, as those are the most attractive induction and conduction pathways for the solar storm. Also, during the peak of the geomagnetic storm yesterday, magnitude 6.7 earthquake struck in the Indian Ocean. It was an above-average day, as magnitude 5s are surging across the globe too, and a 6 hit Panama just this morning. Folks, the plasma release experiment we've been waiting for has been delayed again. No chance for the rocket launch before Friday night, as a safety issue will be checked today, and when they release, it will be a fake auroral glow across much of the eastern US and Canada, and it will simulate what it will look like when the field of Earth actually does collapse. Preview of the end of the world. Let's not stray far for our first story here. Study of mid-latitude geomagnetically induced currents around Japan. In addition to noting the solar flare effect, which it's good to see in its proper place alongside the other geomagnetic actors, they describe how the mid-latitudes are quite vulnerable as well. This is because of the equatorial electrojet and the global electric circuit tied to the ionosphere. Up next is a quick nod back to the issues described in our easy summary on climate science. It has links to our longer examinations and is linked for you in today's list below the video. But let's add on with a confirmation of grand temperature swings during the glacial periods, the magnitude of the shifts. The cold that's coming as this interglacial winds down is about 6 times greater than what they're calling global warming. We are ants on this planet. Let's shift to a recurrent nova, where the energy range has been pegged to be between 10 to the 36 and 10 to the 37 ergs. This is not the smallest of eruptions, but it is a mini nova event. We see stars super flare bigger than this, and this event is only slightly more energetic than what we expect from the 12,000-year cycle solar micronova. As we mentioned last night, we knew we would be doing a third special report in the evening. We just thought it was going to be about the galactic current sheet and solar micronova. Obviously, the sun superseded it yesterday. But to gear up for that next special report when we can get to it, recall that they have tons of evidence of recent, nearby nova, but it's confronted by the fact that that would have destroyed the Earth, and then the magnetic dusty pinball paper showing how once you actually model magnetic fields, the dust is trapped in the remnant, means that our sun is pretty much the only explanation for the deposition. Today, they try to get around that and manage to drop some breadcrumbs while they do. So fine, a supernova would have killed the Earth if it was close enough to do these things, but what about a kilonova, they say? They are now offering a guess of neutron-star merger to try to get around their previous gaffe. And while doing so, they identify numerous other isotopes to look for, which they apparently don't know have already been found in the samples. Additionally, the kilonova events on the record are all over 10 to the 40 ergs. That still would have killed the Earth. Special report on why it is in fact a solar micronova is coming up in the next few days.